So my name is Jovan Strika. I'm representing Macrotik. Macrotik is a manufacturer of networking equipment. We're all based our product on Mikrotik boards, and we are also developer of cloud platform that allows you management and monitoring from the centralized position, centralized data centers, and we're leveraging the Mikrotik scripting for most of our services. Today, I'm going to talk about UPS and what we end up doing for Mikrotik device and how Mikrotik scripting is helping us to achieve a real-time notification of the power outages. I'm going to start with why UPS is important, and then available vendors and models. And then I'm going to talk about our macro UPS that we created for the device. How we connect with the Mikrotik, and also what kind of examples of the source code and APC commands, as well as the scripts we use to achieve this. And if we have some time, I'm going to show kind of a live demo. So UPS, uninterrupted power supply, device that basically provides a power for the device in the case if primary power input is out. When we start looking at research, we found interesting figures from Pricewaterhouse research. We found out that 28% of IT failures are power related. That's a huge percentage. And more than 33% of the companies takes more than 1 day to recover. 10% need more than a week. It takes up to 48 hours if you need to reconfigure network, and that's not just from the point that the power affected and came back, but also in the case if that there is a power surge, which is also another problem that can leave that device damaged and offline totally, which in some cases takes much longer to recover. 90% of the companies that experience disaster recoveries and had no plan of recovery, by the time that they end up recovering and replacing device, very big percentage end up losing customers and not really able to recover after it. So altogether, when we look at what UPS are available, and as you know, there is many different vendors, and all of them have a lot of different models available, and pretty much it is the same story for last decades. You have rack mount or desk mount, desktop or actually floor top models. Pretty much they are all kind of providing a similar option. There is a battery and then add-on management capabilities. What you see on the right side is actually one of the Dell UPSs. This model particularly can support up to 10 devices at the same time. And what you can see also on the managed sort of UPSs, you have USB or serial connection, typically only one per device, that you can connect to either server or any other device in your network, and that will be able to receive information about a power outage or battery status. And typically that's only one connection. So for example, in your data center you have 10 devices connected, and let's say server that receives this information. Most of them, like a Windows for example, have ability to gracefully shut down your database and your applications. But what about other 9 devices? Pretty much they end up experiencing brutal disconnect unless that Windows somehow informs the other devices in the network and get them to shut down gracefully. So that's a big problem. And the second one is that this is single point of failure. So all your 10 devices connected in one UPS, it's clearly creating a risk. And from the point of status on the battery, we have numerous situations where the company thinks, well, we are safe, we have UPS running, but the reality is that over time, battery was deflated, not really tested, and when the power goes out, pretty much all these 10 devices are out in a few minutes, and they thought that they have at least 20, 30 minutes of save time. So when we look at this problem, we wanted to approach in a very different way, and we come up with our own kind of acronym, macro UPS per device. And there is no vendor or device that I'm aware of when it comes to the routers that have UPS built in the device. And when we look at this challenge, we start architecting around Mikrotik device and what are the really features that not only will make it in the box, but also how we can make it sort of better and I would say upgrade the next generation of the UPS per device. We definitely wanted to avoid single point of failure and not have a power range for not critical devices, because if you look at these 10 devices, we find out that often customers are connecting non-critical devices on UPS. So out of these 10 devices, it might be only 5 that are critical, but they end up connecting is because they wanted to protect from power surges, which in this case, it will obviously shorten up the life of the battery if you end up powering devices that are not really critical. Well, so in this case, by doing it per device, then you allocate how long you want that device up and running, and obviously the factors between the battery size as well as the load of the device kind of varies that time, how long this device will be up and running. And when we took into kind of design what we would like to achieve, well, first of all, we went with the hot swappable battery. This, what you see, is a very small 2-cell lithium-ion battery. We can fit the 4 cells, so extend kind of doubled the length of how long this device can be up and running. And for example, if the RB2011 is without wireless, it can power RB2011 over 4 hours. The battery is in separate removable tray, and this removable tray has a thumb screws and allows to take off the battery and even change it without powering off the device. And we end up using this dual conversion UPS, which means that it totally isolates the power source from the board. And in this case, it can be battery as well as not only one, but also second power supply. So you have sort of 3 power sources possible. And by having that input in the device, we're protecting. So in the case if there is any surges or any problems, which heard that often happens in a network, all you can kind of blue is that our power management board rather than your internal router board. So clearly from damage perspective, you can still protect your internal board and scripts and whatever is running, and then replace only power management board. And we are able to have 2 outputs. So what we did, because we started creating additional products that has a Raspberry Pi or some other boards in the same chassis, or external device such as USB modem, the DSL modem, or a telephony ATA, or whatever you might like to connect and use that same built-in UPS. Now this system can actually support additional either internal or external device. And switching is, we were able to achieve 20 microseconds, which is about 20 times faster than any traditional UPSs that are about from 1 to 25 milliseconds to switch it over. We use the solid state rather than relay, so no moving parts. And with the dual power supply, we are able to seamlessly switch between them, but only use one power supply at the same time instead of both of them, like most of the dual power devices does. This is important for example, in our data center, our backup power, the contract we have is on the discount power bar, 20% of the cost of the power bar, but only in the case if there is any usage of that backup power. And by having the device with a dual power supply that drains from both bars at the same time, you will not achieve that lower cost of the power for some data center if they make that available for you. And then efficiency. I think that's really the main and important part, how we were able to extend the time of keeping this device for so long on just a 2-cell battery is because we don't do dual conversion. Every UPS has a dual conversion of the power, meaning coming from AC to DC to charge the battery, and then from battery goes back to AC, gets into your device, then transformer or power supplies turns back to DC, and you are definitely losing quite a lot of power there. So we make it very efficient by not having a dual conversion, and that prolonged the life. So when you look at this board, how we connect to Mikrotik. So Mikrotik has the serial or USB support for connecting UPS. So in our case, we use the serial port, and when we connect to the board, we use the console connection. And in Mikrotik, right from the get-go, you don't get a UPS package built in. This is additional package. You would need to go on Mikrotik's site, download all packages uncompressed, and then upload UPS module. Once you do that, it will show up in a Winbox, for example, on the left side, and then you can start managing UPS. There are a few tricks that you have to kind of be careful, because by default, serial connection is used by console, so you would need to actually disable that use. I'll show, hopefully have some time for demo, I'll show you how that looks like, but you have to disable the usage of the serial port is not used for console, and then it can be then used by UPS module. And once you connect, what you see is this screenshot, you get information that is retrieved from UPS, vendor, serial number, firmware. But then on the right side, you see the statistics. And this is purposely, I took a snapshot of the situation where there was, it is on the battery. So it kind of singles that it's on battery, provides you the battery voltage, and then it has the trigger built in, what to do when you get on the battery, but also what you do when the battery is so low. And you can set up that Mikrotik device will gracefully shut down in that case. But that's great for the device. How you can get the notification information and what else you can do is actually where Mikrotik scripting comes in place. So when you look at the one step back, how they communicate and how communication is happening between UPS and the Mikrotik, it is using just the ASCII commands. It's a one-character string. You send over serial port. You can actually do manually by just talenting or doing the console connection to the UPS. If you set a certain character, you get a response back, and that's how they kind of communicate. And this information is then on Mikrotik's side stored, and the results are stored in its own local variables. What you see here on the screen is the couple of different type of commands, and I provided a link if you want to see what else is available. This is a definition of APC Smart UPS protocol, which sort of became a standard, unwritten standard for the communication, and pretty much all the other UPSs are supporting, because it's mostly supported protocol in the devices. And the way how you can get that information is by using the command in the terminal called system UPS monitor. And it's a very similar information that you get on a screenshot on the right. But what's happening is that here you get just a kind of dump of the results. In order to get them into the variables and use them in a script, on the right side you see an example where you're able to actually sort of read the output into the variables. And then once they're in variables, then you can do some condition checkings and perform different operation based on the results that you get. So the command on the right basically sets the current on battery variable based on the value that is received, if it's on battery or not. So that's actually kind of basis of a very initial script that end up checking what's going on, and by putting it in a scheduler, you can then react every how many seconds you want to get this information, what the status is or not. So I did a quick demo. I'm going to do the quick demo of that communication. So first, the UPS script. There are already some available on Mikrotik script example page. There are a couple of option you can do, and it's kind of available online. You can edit and change your settings. The one of the examples actually sends you email when there is the outage, and I purposely wanted to leave that type of script for you to take a look. It is collecting the data and then evaluating the values, and based on this, if it's a outage, sends email. When it comes back, also informs, but it also monitors the battery level, so you can sort of have, well, this will happen when the power is out, but then this will happen when it's really low and power was not restored. So you have a bit of options how to manipulate this script. But if I log in right now, what you see here first on the menu, so under this system, UPS, this is actually where is located UPS modules once it's installed on the device. By default, you don't have it available, but you would need to first take it out of the system console. And as I mentioned, by default, serial connection is used by console, so you need to first disable usage of the serial port, and then you will be able to add the UPS and assign the serial connection to the UPS module. Once you do that, is what you get here as first information, what kind of UPS you have and the model number. So again, no matter what you have, even APC or any other modules, pretty much these are the traditional standard commands. And then you have a status with a few other features that might not be supported by all the vendors. And then when you look at the script, this script that I mentioned earlier, it's called MCK UPS script. It's wrapped into the scheduler that end up running this every, 5 seconds. So when you look at the situation right now, when the device is powered up, power is out, you get a log message here that it's out and email can be generated. And when you bring it back, then very quickly you get the message that power is restored. So not a complicated demo, but I thought it's good to kind of see in real time how that works. So when you look at this from the point where you go now, from the ability to now capture and understand what's happening with the power, then it really comes into Mikrotik capabilities and your creativity, what do you want to do now with this information. So this is really related to your particular usage of the device in the network. Is it enough just to send email, or you should do more complicated options? So for example, for enterprise customers, what you can do is to turn on the second WAN connections, maybe connect to your tether to your phone, use the 3G LTE connection and then establish it. Rather than keeping it established and using your data plan for 3G, you can do a lot of different type of operations once you know what the status is. You can definitely send email, but interestingly, with a fetch command that I demonstrated in some other presentations, you can sort of send that data to the servers, and that servers could actually, if they have some kind of API, end up performing a graceful shutdown. Depending on what you want to inform, you can create some kind of proxy or list devices that you need to inform on the script. And in that case, unlike with traditional UPSs that pretty much only one computer gets, Mikrotik is capable then to kind of inform the rest of the network devices that there is a failure. You can, in some cases, when there is a failover to 3G or LTE, you can even go further by blocking certain ports and turning on firewall rules that will allow only critical traffic, such as a point of sale terminal or some kind of a voice over IP to be able to go through the route, but not the rest of the traffic, because you want to preserve that that backup link and traffic on it. Update DNS. If you go with a out, and let's say you have a mail server, maybe you want to redirect that mail server traffic not anymore to the office but to a different IP. So there is a lot of different functions that you can do, and it really all depends of what kind of plan would you like to, either if this is device for you or for your customers, what kind of business continuity plan you want to design and how you want to implement. So that's pretty much it for my presentation. Thank you, and do you have any questions? Thank you very much.